Hello everyone, welcome to the walkthrough for exam prep section 3. In this section we are going to talk about regex, so this week we'll be intensively practicing regex and next week we'll get to visualization, sampling, and surveying. So before we start, there's a resource I want to introduce to you, which is this midterm reference sheet. So if you Google Data 100 midterm reference sheet, you will find tables like this that talks about how each regex symbol corresponds to the purpose of it, so you don't have to memorize all of it for your exam. You can just kind of look here and decide what expressions you want to use. But sometimes there are special properties of the symbol, and this table is not exactly extensive of all of their purposes. So sometimes you want to also remember some facts and practice how to use it on your own time rather than just relying on the reference sheet. Okay, so throughout the walkthrough, we might be referring back to this table if we need anything to construct a symbol so that we have an access to this knowledge. Okay, so let's head into the first question. So in this question, the Python regex library has been imported as RE, but keep in mind that pandas.str accessors also have their own methods for using regex-related terms, and it's better that if you are familiarized with both RE and pandas methods. The exam prep worksheet this time does not have any pandas.str accessor methods that are being in the questions, but technically they are in scope, and it's good if you can familiarize with it on your own time, but in the worksheet we'll walk through how to use RE methods because they're roughly similar and it's an easier variant. Okay, and the backslash in strings means breaking line. This is just a question-specific weird thing. All right, now let's talk about influencers and Gen Z pop culture. So Shiny is an aspiring influencer, she's on Toxic, and as a data scientist, she wants to analyze data and understand how her audience responds to her videos. So now she's using regex to analyze her comments. Okay, so first we're going to construct, for this part, a pattern that will capture the next two words that appear after any word containing love in a comment. So usually when we see this kind of problem that warrants a specific pattern, it's good for us to write sub-patterns of regex that correspond to each of the criteria first and then concatenate them together. And then that way it will be easier to solve the question. So although this is a multiple choice question, we can try constructing a pattern and see which option is the closest or most fitting to our description. So there are two criterions in this overall subpart. The first is you need to have a pattern that corresponds to any word containing love in the comments. So any word containing love is fine. And then you need the next two words. You want to capture the next two words, so there must be parentheses around it for a capture group. Okay, so the next two words. Okay, you might need some spaces as well. All right, so judging by this, we can already see that B doesn't make a lot of sense because it's capturing the word love, but it's not capturing the... I don't know why Microsoft is doing this to the software, but anyways, you see that option B is not going to work because it's capturing the love, so this is not making a lot of sense. Okay. Keep in mind that there might be spaces between words. So first let's try to find a pattern that matches any word containing love. So there can be alphabets preceding or coming after the characters LOVE, which you can just write directly. The characters that will come after love is usually an alphabet, so it's something like this. When you have a dash in a character class, it means from the previous character to the next character after the dash based on their ASCII code. Okay, there's an indeterminate amount of such characters, so out of the question mark, plus mark, and asterisk, we will prefer using asterisk because there might also be just no character preceding it, following it. And then, last but not least, because there's a word afterwards, we need a space. So this is the pattern for the first part. Now, coincidentally, there's only this option, option C, that corresponds to the option we want. But let's look at whether the next two word capturing pattern is right. So here, they're using BackW+, which stands for one or more word character. Word character can be hyphens or alphabets, in general, things that are consider it as a character that can appear in a word. And then they have a space so that they can introduce the second word. So it looks like option C is the better choice here. Now, option A doesn't work because it's only using one character. Option D doesn't work because there's no space between the words. Okay, so that's how the first subpart looks like. On to the second subpart. Shiny has heard that internet users will convey strong emotion in comments by ending sentences with repeated punctuation, such as multiple periods, exclamations, and question marks, and consider this to be an extensive overview of internet online human behavior. Now, Shiny wants to write a regex pattern that will fully match any sentence that ends with more than one period, exclamation, or question mark. So, this is going to be slightly complicated, but let's separate this as full sentence and more than one ending punctuation. So the ending punctuation here refers to the period, exclamation mark, and the question mark. Okay, so if you want more than one than this, one of either of these, you can actually characterize this as a character class. So what you can do is to say this is a character class containing dot, exclamation mark, as well as question mark, and then you can have more, you need more than one. So actually this is a greater than, not greater or equal to. And since it's more than one, you can start from 2. So this interval symbol, which you can see from the regex cheat sheet here, can be used. Okay, so we figured out the end. And it turns out that this end was used in every single solution. So now we must also figure out the front. Haha. Now, well, let's parse one by one. So let's look at option D first. Option D has a space before punctuation, but this is against the English grammar, so this is not going to work. Option A, on the other hand, well, this period here means any character, but when the period is used inside the character class, it's just used as a period itself. Same for question mark. So actually, if you do something like a dot, 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 it also fits pattern A, and that's obviously not what we're looking for because dot, dot, dot is not a sentence. Okay, so this is false. Last but not least, option B and not option C. So option B is this character class here is targeting all non-word character, and this doesn't make sense. Because a sentence must have a word character somewhere, so B is also false. Well, now from process of elimination, you can say option C is right, but how right is it? Well, first of all, this caret, when used outside a character class, means beginning of sequence. So we're saying that the sentence must begin with one or more word characters, and then you can use non-ending punctuations for however many times you can use characters that are not period, exclamation, or question mark for however many times as you want because it doesn't end the sentence. And then at last, you can do the more than 2 punctuation that we have here, and that seems like it's going to fit our criteria. Okay, so this subpart is okay for option C. Let's look at the third subpart, which is a little trickier. Shiny will meaning friend tries to help by writing some regex patterns to analyze the comment data. In each of the parts, select the output generated by running the following cell when friend pattern is assigned to the corresponding regex pattern. So let's look at the code first. The code is find all, and so it's going to find all of the matches, and particularly it's going to find the first match of the pattern from this sentence. Okay, so let's become a regex compiler because that's all we do as a data scientist, and try to figure out what's the first pattern we get from this first pattern, which is 2023 question mark. Okay, so 2023 question mark. Well, the question mark here is also a regex symbol. It means 0 or 1 more. It means 0 or 1 time. So technically, both A and D would be okay choices, and B would not because this question mark does not match a literal question mark. So B would not work. And C would also not work because we're just trying to match this pattern, and these word characters are not included in the pattern we want. Okay, so now we must decide between A and D because they're both valid choices. One has a 3, one doesn't have a 3 at the end, and the question mark allows for that. But here's a tricky thing, which is that regex has a greedy nature that tries to take the largest possible match to any pattern. So in this case, A is the larger match, and therefore we will choose A instead of D. So the reason why we choose A versus D, A before D, is because A is a longer pattern, which fits regex's greedy behavior. Okay. And then the next subpart asks what's the pattern that will match this word character plus and then a dollar sign. So whenever you see a regex pattern and it seems kind of mysterious, what you can do is by decomposing the pattern and write out in English what this means. So for example, this is more than one word character. And the dollar sign here is actually not just a dollar sign, it means the end of a sentence or the end of a line. So you're searching for, essentially, the word character the word character that precedes the end of some line. And in this case it looks like haha, because haha is at the end of the line and it's also a sequence of word characters alone. Okay. Now 3. If your pattern looks like this, well, hashtag doesn't mean anything, so it's just hashtag. This is more than one word character, and this is more than one space character. Well, once again, due to the greedy property here, it will try to capture as much space as possible until regex encounters a non-space character. But in this case, there's only one space after every single word, so it's okay. So now we look for where hashtag happens. The only place where hashtag happens is here, hashtag famous, and you capture famous itself, it's 6 word characters, so it's fine, we're going to capture it. There's a space after it, we're also going to capture it because there's a warranted space character here. So the answer is B. Okay, so once again, the key to any single regex pattern question is to decompose it, write it in English, and then merge the ideas you have together. All right. So that's the first question. Now we must head into the second question, which will be a little bit harder because it's constructing a lot of patterns without any hints. Okay, so someone is reading Percy Jackson books in one setting, wants to use regex to find some interesting facts of books, so we're probably going to be using regex to filter out sentences in the books. All right, so assume that the entirety of book is stored in the string book, which would imply that the string begins with chapter 1 and ends at the end of the book. So it's a string that contains every single content inside the book. The first subpart. Define an exclamation as in any quoted sentence of 3 words or fewer that ends with an exclamation mark. In other words, it should begin with a quotation mark, include 0 to 3 words followed by an exclamation point, end with a quotation mark. Okay, it's helpful that they have given us such an amount of information because then we can go back to the previous trick we had before, right? Which is just write down sub-patterns and fill it out slowly based on the criteria we need. So for example, beginning with a quotation mark and ending with a quotation mark is conspicuous, as in it's backslash and then double quotation mark. Okay, now we have to figure out the middle part, which is include 0 to 3 words followed by an exclamation point. So what you can imagine this as is you can have a word pattern that you can just imagine this is like a regex pattern that corresponds to a word. You have it from 0 to 3 times, and then it's followed by an exclamation mark, which can just be directly written here. But what's important here is that you want to actually capture a specific thing, which is you want to capture the exclamation itself. So you need to also put a parentheses around here for capture group. Okay, so now we just need to figure out the word part. So what's the word part going to be? Well, a word can just be a sequence of alphabets, right? Okay, but then you also need spaces after a word, but you could also be at the end of a sentence, so you can either have a space or not. To either have a space or not, you can use question mark. But here, sometimes you can assume that you have arbitrarily many space marks, so you can also just use star. The solution uses star, but I think question marks would work. Because you would either have 1 with 0 space after each word, assuming it's not ending the sentence. Okay, so either a question mark or a star here would have worked for the context. All right, so now we have the entire pattern, which after summarizing all of the notes we have here is first a backslash, double quotation, The backslash here is still needed even if we're in the raw string, because the raw string begins with a double quotation. If you use a single string here instead, everything should be fine. Okay, so now the word pattern. A to Z plus backslash star. You need this. And then what you can do is then you can add in the bracket symbol we have here before, which is 0 to 3. So actually you need to do 2 capture groups at the same time for you to capture the entirety of this. So once again, the word pattern, whether you have a backslash or not, it's okay. Do it 0 to 3 times. Another quotation, another parentheses, exclamation, and then backslash, double quotation. Okay, well, the thing here is that the cell's pretty small, right? But during the exam, we'll give you a larger cell. Okay, well, we use 2 capture groups here. It's kind of problematic. We have to decide which one to use. But it's the first capture group, which is the larger one here that we want to capture, because that's the entirety of 3 words, 0 to 3 words. So we'll use group number 0, which means the first group. The first group happens based on the order of the left parentheses. For example, the larger group had the left parentheses happening first, so it's going to be the first group. Okay, now, next part. Write Python code to capture all sentences that constitute an entire paragraph, and assign the result to the variable result. Okay. So what we can do is we can try to figure out what does it mean for something that constitutes an entire paragraph. So for something to constitute an entire paragraph, we can consider the property of a paragraph. Usually when you write things, the paragraph looks like this, right? And then you enter break line and then go into the next paragraph. So what this means is that a paragraph is actually just anything that happens before a break line and possibly between break lines. Okay, so what this means is that to capture a paragraph, you can first have a break line or not, and then due to the greedy regex property, if there's a break line, it will capture it. Okay, and then just circle everything that is not a break line. There must be something between there, so it's plus instead of star. And then at last, you can have break lines. You can have however many break lines you want, really. So you can use a star here, and by the similar logic, you can also use a star here. Sometimes people type 2 lines instead of 1 for a paragraph. Okay, but actually, this is not quite needed because because imagine there's 2 paragraphs, and the first paragraph just starts there, then the backslash n, well, this pattern would have still worked, but the backslash n at the end is just going to eat away the beginning backslash n you have here, so we can just have it at the back, and it's okay. By similar logic, you can probably also have it at the front already. And in that, but then in that case, what happens is you have this pattern, and it will actually, yeah, it will still work fine because if you match it towards the first paragraph, there's no break line in front of it. If you match it towards the second paragraph, it's just going to eat away all the break lines between the first and the second paragraph. Okay, so either of this would have worked. The solution prefers the latter because sometimes there's no break line in front of your paragraph, especially if you're at the first paragraph. So we'll use that version. Okay, but rest assured that when we're writing exam questions, we'll try to make there only one unique solution for each of the patterns, so it's easier to grade for both you and TA. Oh, we still have to write a Python code to capture all the patterns that match what we had before, but we actually did something very similar before for capture groups. It's just using read.final. So let's just use read.final. And the syntax for that call is going to be first you put in the pattern you have and then the string you have. So pattern, comma, book. Okay. Well, you know, this all sounds very abstract, but you can test things out at regex 101, and you access that website by Googling regex 101, and you will be allowed to key in a lot of test cases and test your regex phrases, and that's a very convenient tool for you to practice regex. Right, so, well, that's enough yapping about regex, and now we should probably move on to the next part. So the next subpart, using regex, write a Python code to return the list of first word of each sentence that contains the word prophecy at least once. You can ignore sentences that start with the word prophecy. So what we need to do is first to figure out how to write a sentence, and then later we can try to figure out how to write a sentence with the word prophecy. So first of all, a sentence looks something like this, right? Where you can have a starting word that where the starting word must be a capital case, must have a capital case ladder in front of it, and then, well, you can also have spaces in there, I guess, or you can have quotation marks. So actually, this becomes very complicated. So why don't we just actually circle up the first word. And it could have a space after it, but it could never be something like an ending punctuation, right? So we can write characters that are not ending punctuations until there is an ending punctuation here. So this would be a good pattern that matches up a sentence. So once again, this is the first word, because you must start with a word. And then this is anything in the middle of sentence, which is just nothing similar to an ending punctuation. And then this is the ending punctuation. Okay, so that constitutes a sentence. Now we just need to figure out how to make sure the sentence definitely includes prophecy. So there are two ways that prophecy can be involved. The first is that you can probably have the prophecy as a first word, but in the question, the word prophecy is used with a lowercase, so we can also, and then it also says that we can ignore sentences that start with the word prophecy. So we'll just deal with the other case, which is prophecy is in the middle of the sentence. So if prophecy has to be in the middle of the sentence, then it must be a lowercase word, and it is probably following a space. So you can add something here that says prophecy. Okay, but then doing this, you might have some other non-ending characters that follow it, right? So you can add non-ending characters that follow it. You may or may not have this because the prophecy might be the end of the sentence. Okay, so with that logic, we have actually just concretely constructed this pattern. Okay, so let's outline the logic here. First, try to find a pattern capturing first word of a sentence. And secondly, put in the prophecy constraint. Okay, so you're in a philosophical sense, you want to do things hierarchically, which means you want to deal with a large problem by breaking it down to sub-problems and working with different constraints one by one. So it's easier for you to navigate through the entire solution, and it's easier to test the solution as well. Because if one part of the solution doesn't work well, you probably already know which part doesn't work well, rather than trying to tackle the entire large expression in one go. Breaking the question into parts is a very valuable skill in data science, and so is it in writing regex patterns. So break things down and then construct the pattern. So for example, in this case, we constructed this lower line using for completing task 1, and task 2 was this prophecy, and then this is non-ending characters, which can be in the middle of the sentence. And then we have an ending punctuation later, inserted after we add this pattern. Okay, last part. Suppose we wish to extract the most common names preceding a question mark. Okay, most common names preceding a question mark. How do we build a pattern for that? First of all, sorry, never mind. The question already hints you. Okay, we do this first by extracting all words that begin with capital words that precede a question mark. Okay, so words that begin with capital letters, let's assume that there's only alphabets in your name, or you could also have dashes. That's a trickier one. So you can have a capital letter, and then you can have words So, well, you can just also use a word character, and then you can have however many characters you want after your name, as long as it's not a space or a non-word character. So this is going to constitute a name. And then it precedes a question mark, which means immediately after this, what you capture, because you want to capture a name, you put a question mark. But keep in mind that question mark is a special character, so you must escape it or make it not special anymore by using a backslash. So now a question mark is no longer your special. And you have this pattern, which corresponds to the name, and then a question mark that is not a special character. This looks like exactly option C, so we will choose and go ahead with option C. Okay, so we're going through some questions quite fast and explaining the logics within it, but when you're practicing, it's fine to go slower, and make sure you learn how to break questions into subparts before you tackle the larger question, because that's going to help you speed up your solving process and also going to help you digest the material a little deeper. Okay, that's it. Have a nice day. Bye-bye.